This problem has one polar equation, r equals to 1 minus 2 sine of theta. And then when you sketch the graph, I prefer using decimal. This is the graph. They are looking for find the area between inner loop and outer loop. This is inner loop, this is outer loop, and they want the purple region. Okay, do you see that usually in this type of problem, they do not give you the upper limit and lower limit? You know the area, how to set up an integral to find the area of enclosed by a polar curve. But what about the upper and lower limit? From where to where, the definite integral. That is the hardest part. Okay, this one for inner loop. So what I recommend you to do is using decimal. And then do you see that I just graphed the polar equation, 1 minus sine 2 sine theta, and then they gave me that one full graph is from 0 to 2 pi, all right? And then I went to the next line, I graphed the same polar equation. Why? Why do I need to do this? Okay, this is for you to find the upper and lower limit. Most people may think, okay, how come, most people may ask me, hey, right here, how come you don't start from 0? How come you don't go from a 0 to theta and then to pi over 6? How come you don't do this? The reason is, if you go from 0 to pi over 6, you will only get this piece. Do you see the green piece? You will only get this piece. This piece is not part of the inner loop. Once again, from 0 to pi over 6, you get the green piece. That is not part of the inner loop. That's why I cannot go from 0 to pi over 6. Instead, I will start from pi over 6. Let me erase that piece as well. I will start from pi over 6 and then less than or equal to theta, less than or equal to, I will do a 2 pi over 6, and then I will do a 3 pi over 6, 4 pi over 6, and then 5 pi over 6. I will just keep changing the number next to the pi. 1 pi over 6, 2, 3, 4, 5 pi over 6. And then as you can see, that once you reach to 5 pi over 6, you will get the entire inner loop. So that means the lower limit and the upper limit to sketch the entire loop is from pi over 6 to 5 pi over 6. That's why I recommend you to doing this in decimal. You graph the same equation one more time, and then you are changing the upper and lower limit until you get the piece that you want. Okay, for the inner loop, you know what? The next graph, by the way, before I set up anything, how do we get this region then? This region, you didn't shade the inner loop, but now you are looking for the area of the inner loop. Why? So here is why. First, I find the area of the inner loop, which is the purple region, and then I use the same technique to find area of the outer loop. Which is this region. So let me shade that region for you as well. So I will use green to shade that region. So that is the outer loop. So when you look for the outer loop, then that will be including this as well. This is my outer loop. Okay, let me quickly shade that region. This is the outer loop. And then I will use the green region, subtract the purple region, meaning that you have the green region, you take away this region, and then you get the area in between the inner and the outer. Just like area of a ring, you use the area of the outer circle minus the area of the inner circle. And then as you can see in this step, I keep tracing, and then I found that this one, I start at 5 pi over 6, right? And then I start at pi over 6. I am increasing the 5 pi over 6 to a 6 pi over 6, 7 pi over 6, and then eventually I will reach to 13 pi over 6. And then I realized that from 5 pi over 6 to 13 pi over 6, do this in your decimal. You can see that they will sketch this one piece at a time, and then they will eventually, when you reach to 13 pi over 6, they will finish the entire outer loop. I want you to take the advantage of this in decimals. So that helps you to determine the lower and upper limit. Okay, back to our business, the inner loop. Let's do it. So the inner loop, let's write inner loop. I will use purple for the inner, use green for the outer. Lower limit, pi over 6. Upper limit, 5 pi over 6. And then the area integral, that is integral from pi over 6 to 5 pi over 6. And then you have 1/2 times the square of the polar equation. 2 sine theta square d theta. Okay, let's pull the 1/2 out. And then you have integral. Okay, you square that 1 times 1 minus 2 minus 2, that is minus 4. And then 2 times 2 is 4. And then you have a sine square theta. And then you have a d theta. Okay, this one I said this many times. When you integrate, you cannot integrate sine square. And then you cannot integrate cosine square. When you see them, you have to use a power reducing formula. So here is a power reducing formula. For sine square, to reduce the square, you have to write that as 1 minus cosine 2 theta and then divided by 2. And then now you can integrate the 1 and the cosine 2 theta. Okay, let's put this piece in. You have a 1/2 integral. And then 1 minus 4 sine theta and then plus 4 times 2, 1 minus cosine 2 theta, and then I am running out of space to write the d theta. The 4 and the 2 can be simplified, and then you have 1/2 integral from pi over 6 to 5 pi over 6, 1 minus 4 sine theta, and then this one you have a 2 in front, right? You distribute the 2, and then this is you need to do a distribution. Then that will be a 2 minus 2 cosine 2 theta d theta. And then 1 plus 2, you have a 3. Okay, let's move this up. 1/2 integral 3 minus 4 sine theta. You can integrate one term at a time. Okay, then we are ready to integrate. Okay, 1/2, the integral of 3 is 3 theta. The integral of sine is negative cosine, then plus 4 cosine theta. The integral of cosine is sine, so you have a 2 sine of 2 theta, and then you need to prepare a 1/2 because by chain rule, the derivative of this that produce a 2. You need that 1/2 to get rid of the 2. Lower limit, upper limit, and then we are ready to do a plug-in. Okay, this is 1/2, and then I have a 3 times 5 pi over 6, and then plus 4 cosine 5 pi over 6 minus sine 2, and then the 6, then that will be a 5 pi over 3. Okay, upper limit is done, minus integral 3 times pi over 6, and then plus 4 cosine pi over 6 minus sine 2, that will be a pi over 3. Okay, this one, hopefully you still remember your unit circle. This is 5 pi over 2, and then plus 4 times cosine 5 pi over 6 is negative root 3 over 2. Sine 5 pi over 3 is negative root 3 over 2. And then this is a pi over 2 plus 4 times root 3 over 2, and then minus root 3 over 2. Actually, you can take the 1/2 outside, and then just do the simplification, just do the subtracting and adding inside. But be careful, here is a minus, so you will have to distribute this minus to every one of that. Okay, let's bring the 1/2 out. So I have 1/2, take it all the way out. And then what do I get? I have a 5 pi over 2. And then this one is negative 4 plus 1, right? Do you see that? Negative 4 plus 1. Negative 4 plus 1 is negative 3 root 2 over 2. And then minus pi over 2 minus 4 root 3 over 2 plus root 3 over 2. And then this 2. Okay, let's use a highlighter. And then these 2. And then the rest. Okay. I have 1/2. What do I get there? That is 4 pi over 2. 4 pi over 2 divided by 2. 4 pi over 2. That means 2 pi. And then what else? Negative 3 minus 4, negative 7. Negative 7 plus 1 is negative 6. Negative 6 divided by 2 is negative 3. So that is minus 3 root 3. And then you can distribute the 1/2. Then you have a pi minus 2 root 3. No, not 2 root 3. Pi minus 3 root 3 over 2. So all that just for the inner loop, area of inner loop. Where is the inner loop? Let's take a look again. Inner loop is that little purple piece. The area of that is right here. Okay, let's find the green. Okay, we stop at pi over 6, right? And then we stop at 5 pi over 6. That is the upper limit. And then I keep moving. 6 pi over 6, 7 pi over 6. And then once I reach to 13 pi over 6, I see the entire outer loop. And then that will be the area of the outer loop. So I will say area of outer loop. That is alpha is from 5 pi over 6 and then to beta, that is 13 pi over 6. And then therefore, the area is equals to integral from 5 pi over 6 to 13 pi over 6. And then you have 1/2, you square the polar equation, 1 minus 2 sine theta square d theta. So this one will be the same integration process. Exact same integration process. The only difference is these two values are different. So this will be from a 5 pi over 6 to a 13 pi over 6. And then this one, I already did the math. That is equals to 2 pi plus 3 root 3 divided by 2. That is the area of the outer loop. And then we will use the outer loop minus the inner loop. What is that? That is a 2 pi plus 3 root 3 divided by 2 minus the inner loop. We got that right above. That is a pi minus 3 root 3 divided by 2. What is that equal to? 2 minus 1 is 1. So we have a pi. And then 3 plus 3. Am I right? 3 plus 3 is a 6. 6 divided by 2 is 3. Okay, then this is area between two loops. So area, let's use orange. Area between two loops. Okay, let's get that picture real quick. So I'm going to copy and then paste that right here. So using the purple, so using this little purple piece, and then we have the green piece, take the green, and then delete the purple, and then you have the area between two loops. So all that just for this answer, pi plus 3 root 3. All this work just for pi plus 3 root 3. Okay, that is the end of this problem. If you think this is helpful, this is something that you would like to see, click the like, click the subscribe, and I will meet you all in another video.